Question is the treatment of alkyl chlorides with aqueous KOH leads to the formation of alcohols. But in the presence of alcoholic KOH, alkenes are major products. Explain. In an aqueous solution, KOH almost completely dissociates into OH- ions. We know that OH- ions are strong nucleophile, which leads to alkyl chloride to undergo a reaction to form alcohol. But an alcoholic solution of KOH contains alkoxide, which is RO- ion, which is a strong base. Thus, it can remove hydrogen from the beta carbon of the alkyl chloride and form an alkene. The OH- is a weaker base than RO- ion. The basic character of OH- decreases in aqueous solution, therefore it cannot remove hydrogen from the beta carbon. So when this reaction takes place, no alkene is formed, only the Cl gets replaced with OH. But when this R group is reacted with alcoholic KOH, this alkene is formed because it is much more acidic in nature. Because basically what happens that this RO- group is much more uh, stronger base than the OH- group.